So, my talk is on the OWASP Top 10 of 2013. This is basically stuff that is not flashy anymore, and so people don't care as much, but frankly, these are still the obvious things that as as developers, we kind of fuck it up. Well, let me first ask, do I have any software developers in the room? Close enough. Okay. And this might be some information for blue teamers to pass on to their dev department, but it's primarily for the devs who are creating the stuff that, the holes that the red team is, abusing so much. A quick disclaimer, the opinions, rantings, et cetera, only my fault, not my employer's, not the hotel, not the con itself. If I screw up, it's my fault, mine alone. And yeah, that Venn diagram, my boss was going to put that on a t-shirt for me to wear to the con, but they never really got that together. So yeah, they emailed me a drawing from the whiteboard. I thought it was amusing. Also, I love my job. Okay, who am I? I'm a professional web developer for the last 4 years, software developer for 7. I've got a few other thingies. I've got a degree, I've got a cert, I pick locks in my spare time, blah, 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 don't care. Okay, so what's the OWASP Top 10? These are the 10 most common vulnerabilities in web applications, as ranked by the Open Web Application Security Project. OWASP itself is an organization worldwide trying to improve the security of the web. And they do this by providing information, guidance, and bits of software to ease the task that is otherwise Herculean and incredibly difficult. The thing is, with the top 10, they're sorted in this special sauce of most common and most severe, but it's like jumping across the stack of if you actually want to do these in order. So I am going to do these in a different order, because this way, if I gloss over something, you can figure out what I was on about based on what was immediately before it and after it. Frankly, 1 through 5 are all don't trust your users because they're stupid or malicious or both. Beyond that, it's play nice with your config team because they're actually looking out for you, and you try answering a Nagios alert at 2 in the fucking morning. Oh wait, most of you have. So let's get right into it. We will start with injection because this is both incredibly common and incredibly severe. Obligatory XKCD slide. I mean, I'm sure that I would be kicked out of here if I didn't have one of these. But the basics behind injection is people pass data to your website, and through poor sanitization, it becomes executing code. Usually it's referring to SQL injection, but you can inject other kinds of code as well. The only difference, well, the primary thing about this is it's stuff happening on your server. So you spend all this time trying to lock down your server. Your config team has, they rotate keys constantly. They've got the firewall locked down. But really, people are just messing with your data through port 80 and port 443 because, the web application's not locked down properly. So yes, untrustworthy data becomes executing code. Here's a couple examples. First one, written in C#. I know, but it looks close enough to C++. It'll be fine. This is a classic example of a SQL injection point. We're taking raw text off of a request from a user, unvalidated, and sticking it straight into the SQL query and sending that off to the database. The implementation of the data persister class is beyond the scope of this talk, partly because it doesn't exist. The other example I have looks like SQL because it is. There's a common misconception that if you write sprocs, or stored procedures, and do all of your data access through that, you're more secure. Yes and no. Even if granted, you can lock down, truncate, drop, et cetera, permissions, but if your sproc itself still has a SQL injection point, you've basically just made your app harder to maintain and not secured anything. It's sort of a false sense of security. I personally have a problem with sprocs because of those things. I understand they can be used well, but yeah, not a fan of sprocs. Similarly, if any of you use Hibernate or nhibernate, there's this pseudo query language called Hibernate Query Language, or HQL. HQL is a thing, or HQL injection is a thing. People do string concatenation writing up their HQL because it gets you some ORM-ishness to your code, and it's still somewhat fast, but yeah, there's still an injection point there. But all's not lost. We can block these things. First off, don't trust your users, healthy dose of skepticism. But my favorite thing is use an ORM and use it correctly. An object relational mapper might give you a little bit of a speed hit, but 1, it immediately clamps down SQL injection. 2, it gives you a huge boost in refactorability of your code. So if you're a dev, ORMs exist for a reason, and there's a bunch of them for any platform that matters. If you can't use an ORM for one reason or another, there's parameterized queries, which looks like string concat, but it's not, and it's basically built in. It's built into any persistence layer that's worth its salt. It will automatically escape your parameters so that you're not subject to SQL injection. But if you can't do that, use a type-safe language with managed collections, which those are readily available. I mean, granted, you still have to do the hard work yourself, but if you cast IDs to proper data types, you can't inject anything through an integer or a GUID. It just doesn't happen. It's very cleanly in a data context. Other things, you can escape string values. The simplest way is just replace a single quote with a double or with two single quotes. Not great, but it works. And if you're using managed collections, oh hey, you don't have buffer overruns or underruns anymore because it's managed. Something else is taking care of your garbage collection, and something else is making sure that your users aren't suddenly mucking with memory they're not supposed to touch. But failing changing what your language is, your chosen language or libraries, at least validate your inputs with a safe whitelist. Whitelists are, it's kind of, it's a cliche at this point, but it's still true. Whitelists are better than blacklists because they work. They're annoying to maintain, but they work. Or regex. Regexes work, although keep them simple. I'm reluctant to recommend regexes because, as the saying goes, a developer will have a problem and think, oh, I'll use a regex. Now that developer has two problems. And so some people will consider client-side validation. I have to bring this point up because, frankly, client-side validation will not protect you from anything. That's something happening on the client which you don't control. Now, granted, client-side validation is a huge benefit to your user experience. It'll cut down on noisy traffic to your server if you can get a bunch of your validation done client-side. But it's not going to actually protect you from a determined intruder. You still can't trust user input. So at this point, presumably, you've locked down your server. Your data is pretty well safe. So the next thing is your attacker is going to attack your customers. Cross-site scripting is our next one, and very much like SQL injection or injection in general, untrustworthy data suddenly becomes executing code, generally in the context of JavaScript. And so, hey, through the looking glass, as it were. We trust our own data. So a lot of times, a potential injection attack might have made it through to your database, but it's escaped. It's fine. It's not going to actually muck with your own data. But it can get well, I shouldn't say reflect, that means other things, but it can get bounced back out to your users. And just because it doesn't attack your server doesn't mean your users are safe. And once they're owned, you've got owned users who probably have legitimate credentials on your machine, so kind of not good. Insecure JavaScript APIs are a similar issue. I have an excellent example of what happens when we get overconfident and we trust things that we shouldn't. So let's say you've got an expensive IDS, and it's got a fancy web interface because it's new and it's fancy. But it's an embedded device. I mean, there's not a whole lot you can do to mess with its internals. It's all locked down, firmwares and such. So an attacker logs in from outside. And it fails, of course. The attacker didn't actually have the right password. The admin access probably isn't even allowed on the outside. But it sends an email to the admin saying, hey, you should look into this because someone's poking around where they shouldn't be. So the admin checks in from inside the network. But that failed login actually included some JavaScript. And now the admin's owned. And this has actually happened. I'm sure it's happened more than once. This is why we need to pay attention to these things. Again, we can do something about this. First off, encode everything by default. Don't trust anything. I know I'm beating on the paranoia wagon a bit. I don't even know what that means. But if you didn't hard code whatever's getting sent out to the user, HTML encode it. Just don't trust the dev down the hall. I'm sure you work with really competent people that you respect. I know I do. But I'm still not going to trust that they have sanitized data properly. Because that little bit of complacence is how these things happen. And that's why we can't have nice things. If you're repeating something out to a website that's going to be in the context of JavaScript, if it's data potentially spitting a JSON object out to, for your JavaScript to work, beware because JavaScript encoding is different from HTML encoding. So just be aware, encoding it one way might not work well with the other way. Best case, you'll just have some weird code that doesn't work and you have to wonder about these JavaScript errors, but at least that's not attacking someone. If people need to input style information, really you shouldn't be allowing HTML input, but I understand. There are other ways of getting style information. Wiki syntax is good. BB code, Markdown, or if you have to use HTML because your users demand it, use a safe HTML subset and still strip out scripts. Because, again, that's how that stuff gets in there. It's users who are either incompetent or malicious or both. If you're using Microsoft platform, IIS has has request validation. It's a safety net. It's very simple. It's overly strict at times. But turn it on. It will save your butt more than you realize. If you have to turn it off for one page, opt out for that one page and be aware that you've turned it off for that one page and actually lock stuff down. Browser security directives are probably a talk in and of their own, but they're pretty freaking awesome. You can block cross-site scripting as well as a number of other things just by telling the browser, hey, don't cache this. If you see inline JavaScript, ignore it. There's cool stuff like that. But because it's not universally supported, you can't rely on browser security directives. Threat modeling, this is widely recommended by OWASP. I'm not going to go into that because there are at least 2 talks at this conference. I think there's at least 2 later today on threat modeling. So I'm not going to go into that because I don't want to steal their thunder. So at this point, no one's injecting malicious code into your server, and you've probably locked down cross-site scripting directly to your users. So the next step is attackers are going to trick your users into going to their site. So instead of bouncing drive-by downloads off of you, yeah, people will just follow redirects. Browsers do what you tell them to do. So next step is unvalidated redirects and forwards. This is basically someone is taking your trustworthy site and tricking your customers who trust you into going to their malicious site, which is going to abuse Flash or Java or some other horrible thing that you've probably that your users probably still have installed, probably Comet Cursor or something dumb like that. It's not just the domain though; it's anything that can be packed into that URL can be a risk. And so sanitizing that becomes kind of a pain in the ass, but it's necessary. This is a common tool in phishing. Unfortunately, there's not a whole lot you can do about sanitizing people's email that is being sent by other people, but nasty URL redirects are kind of a thing. Like I said, you don't control the destination. Whitelisting this is a pain in the ass. You don't know the names of all of the malicious sites because you'd have to enumerate, malicious site foo Q8753812, through 100 billion. And you can see links like this. And granted, they're all bogus, but, Although, honestly, that eBay link looks really sketchy. I don't use eBay. But you'll notice this one, Google. Yeah, the major internet company kind of doesn't sanitize this one that hard. They trust their users. So don't feel bad about it if you missed this point. That's actually the last of the top 10. But there are ways of going around this. Again, whitelists. Pain to maintain, but whitelists. They work. Don't trust user input. If it's, say, redirecting people based on a query parameter, you can use enumerated values. Have a whitelist of string values that say, like, oh, go to the registration page, go to the schedule page, instead of, oh, follow this whole URL to malicious site.whatever. You can warn the user where they're going. I know of a lot of websites that will say, hey, you're leaving our site, by the way. Are you sure? Although I think that's really just Facebook trying to keep people reading people's stupid Facebook posts. But at least give your users some agency, inform them that they're about to do something they probably don't want to do. Again, browser security directives. People will pack JavaScript into damn near anything these days because it's supported damn near everywhere, including in Twitter applications. I don't know if you saw what happened to TweetDeck. But yeah, this is, it's still common. It's just not as severe. So you've prevented people from directly messing with your site. And you've prevented attackers from directly messing with your clients. And presumably you've prevented your customers from getting driven off to malicious sites that you don't control that would probably be drive-by downloads and such. Well, attackers are still not done. Because maybe your data is still readily available and they don't need to inject anything. This is basically what happens when you expose obvious IDs in the query string and a user can just write a curl script that pulls down however many hundreds of, who knows, they could be law enforcement personnel records, they could be certifications, they could be people's social security information, who knows. If this stuff is publicly available, people will write a script to run through all this crap. Basically, if the user can find it, they will. Easily discoverable IDs like monotonically increasing ints are a common problem. If you're, say, using GUIDs, proper GUIDs, not, sequential GUIDs. Don't get me started on sequential GUIDs. But GUIDs will protect you because then the user has to know exactly which grain of sand in the universe to find. And you're not going to run through the whole GUID space on your website. Doesn't matter how many records you have. This is a form of security through obscurity, which roundly everyone knows does not work. So a couple examples. And yeah, they're kind of straightforward. If someone could just, say, go to a profile page and flip the mode to edit, yeah, that's bad. Similarly, you know, access user stuff, these are all just kind of thrown together, really. The JavaScript API-looking one, though, I had to throw that in there because, frankly, yeah, people can do stuff through JavaScript APIs too. Although this bleeds into the next point. But again, just validate their every request. If you're a good software engineer, or at least lazy, you'll write a good centralized permission checking module. And so on every request, it's, oh, user is so-and-so. Can they access this? Yes, good, send them data. Can they access this? No, tell them to piss off. Done. And honestly, this becomes quite reusable. There's also a technique of using indirect object reference mapping. I'm reluctant to recommend this because either you have to create persistent links that people can keep reusing, which means you have to hold on to these links, which means goodness knows session bloats up or they die, or they have to be persisted, which kind of defeats the purpose, or they become links that kind of disappear as, you know, as the user navigates. But basically the idea with indirect reference mapping is instead of presenting a raw query string or such, you know, or IDs or whatever to the user, you wrap that up, stash in a dictionary value, you give them a GUID, and then the user then hands you that GUID, and you go through the session. It's like, oh, that one, okay. There's really no guidelines on how to put this together in a useful manner. There are some examples that I really don't like. That's kind of, yeah, that's why I crossed it out. Next one's kind of the other side of the coin. This isn't so much reading data as what can people do. And they might not be getting data back at all, but essentially if your UI indicates that there's a profile edit page somewhere, people are going to find that. And maybe they shouldn't have access to it. Again, validate permissions on every request. Lack of server-side validation is going to nail you, especially on this one. Again, JavaScript's just not, I've already ranted on about client-side checks. We all know that client-side checks are bogus. And we, hold on, I have some notes on here that are useful. Or no, we don't. Oh yeah, server-side checks that rely solely on user input. That's basically if the user says, I'm supposed to be editing this page, the server lets you do it. It's lack of permissions checks, all again. Trusting the user, bad idea. So like I said, check the user's permissions when they navigate. Oh hey, on that last point with the direct object references, we've already written a permission checking module. You've already got that. You got that for free on this point, basically. So you might as well use it. Same permissions, it's basically the same checks. Again, server-side checks. Client-side's great for user experience. It is not going to protect you from jack shit. Okay, so at this point, your attacker can't directly attack your data. They can't attack your users directly. They can't direct your users off somewhere. They're not able to go willy-nilly looking at your data themselves, and they're having a hard time messing with your data either. So the next step is your attacker is going to have the users do it for them. So cross-site request forgery is basically the user is able to do stuff without their knowledge because you're not forcing them to validate that they actually know what they're doing. Malicious scripts will do this pretty often, and yeah, it seems very cross-site scripty-y, but it's listed as a different data point for some reason. Who knows what the cordyceps is? You are allowed to raise your hands if you've heard of cordyceps. The cordyceps is a fungus that the spore gets onto an ant, And the ant freaks out, spore gets into the ant's brain, the ant suddenly finds a plant, starts climbing up to the right place for proper sporulation, clamps its mandibles down hard on the plant, and dies, and then a mushroom grows out the back of its head. Because that fungus can't get there itself, so it kind of turns the ant into a zombie to do its evil bidding. This is the stuff of nightmares, yes. And there is one, and funny side note, there is one species of cordyceps per one species of insect that it affects. It is a very solid one-to-one species to vulnerable host. But cross-site request forgery is also basically a solved problem. The most common technique is you provide a pseudo-random token to your user one step before they're about to do something state-changing, and then when you click buy or send money or whatever, you pass that token back. And so the server says, okay, not only is the person telling us all the right session info, but they've passed back this token that they could only have if this were a legitimate user. Microsoft's MVC framework provides this for you. It's a snap to integrate. OWASP provides CSRF guard, which is available for Java Enterprise Edition. It's available for .NET. It's even available for PHP. Don't know why you're trying to write a secure site in PHP, but I don't judge. Now, alternatively, say if you didn't sign on for Amazon OneClick, or if you're changing your password in most sites, you can just require the user to re-authenticate. This is extremely common, as anyone who has changed their password on a without requiring password recovery. You have to re-authenticate with your previous password who the hell you are. And generally, just being directed to a malicious URL to send a bank transfer, that's not going to pack your password in there. It just doesn't happen. Although if they did, game over. You're already owned at that point. If you're using REST, then all of your state-changing operations should require a post. I know I'm spitting out some random four-letter words here, but trust me, look it up. State-changing should not be gettable. That's dangerous. Now we're starting to get into where the lines blur between development and configuration. Because while it's my responsibility as a developer to integrate various libraries, it's config's responsibility to make sure that all this stuff is available, the server is configured, and ready to do what I need it to do. So, like I said, blurring a bit. But broken auth in session management is one of those things. It's, again, fairly common. Unprotected auth credentials, say storing them plain text in a cookie. Using easily guessed or faked credentials is a huge problem. It basically means you're not trying. Exposing session IDs in the URL, just don't put things in the URL that are important. That should be stashed in session. It's passed along in a way that you can't muck with the query string. Not failing to rotate and clean out session IDs is a fairly common one. If, say, I log into a website and I'm still using the same session ID from before, that means my session ID has been live for a long time, and someone has had time to figure out that session ID. Similarly, sending unencrypted auth credentials. Granted, you might not have a means of sending encrypted auth credentials. If you don't have SSL available on your server, you need to tell your config people, hey, we need SSL support. This is kind of important. Hopefully, you're one of those config people saying, hey, devs, why the hell are you not using SSL? But, solve problems. For basically every platform, there's a perfectly good session management and auth management package that's considered good enough by the community. If you can't find one, pick a different platform. Because seriously, they exist. If you roll your own, just don't. Common trope, people write their own session management. It's something that's incredibly complicated, and they think, oh, this is simple. No. Rolling your own session management, it's like rolling your own crypto. Just don't do it. Expiring sessions both manually and automatically, that basically means when the user clicks log out, their session is dead. Expiring sessions automatically means it times out. That means when I've ignored my banking site for 5 minutes, it says, hey, still there? Well, too bad, you're logged out now. You have to log in again because we don't know what you're doing. Which is actually a really good idea if, say, you're in some third world country at an internet cafe and you have to wire transfer or get a wire transfer because you have to maybe afford an airlift or something. But you better log the hell out of that website when you're done because you don't know who's going to get the computer after you. Using SSL, I should probably be saying TLS, but it's the same thing at this point. Or it means the same thing. They're interchangeable. Protect your credentials. Salted hashes are good, especially password storage, this kind of thing. Is bleeding into the next slide a lot. Recovering passwords via reset. Never email a password. I recently bitched out someone for emailing me my password upon login. Actually, I also bitched out someone for emailing me my credit card info. They were very embarrassed about that. I'm like, yeah, thanks. I need to go get a new card. I'm going to send you a bill for the new card. Much obliged, people. Okay. Oh, too soon. Although the next slide's a pretty good one. Now we're getting to sensitive data exposure, which does dovetail nicely with certain config issues such as not using encryption. If you're storing or transmitting information that the user has no need to know, you're asking for trouble. This includes things like comments in JavaScript and markup even. If you're, say, dumping a stack trace because there's a bug you didn't know about in your website, well, this is giving an attacker a lot of information into the internals of your website. And this gives them ammunition that you really don't want them to have. So this is still kind of important. Similarly, debug symbols in your executables. Granted, I'm talking mostly about web applications, but it's still kind of a thing of disclosing sensitive information that you maybe don't want to just hand out. If you're not encrypting your sensitive data, again, this is largely, well, primarily it's passwords, usernames, auth, that kind of stuff. But also if you're storing sensitive data, if you're responsible for social security numbers, driver's licenses, other personally identifiable information, encrypt the sensitive data, because you never know who's going to eventually get hold of your database. Who knows? Maybe they'll just drive a truck up to the server room and walk out with your hard drives. If you've encrypted the data, you've at least bought yourself time. Who knows? You might have even thwarted someone getting data out. But again, encrypting is nice, but if you're using old or weak crypto, or say weak keys, stale keys, if you don't rotate your keys every so often, that means you're still going to be asking for trouble. Old crypto is old for a reason. People stop using old 56-bit desks for a reason. It's weak. If you rotate your keys sooner, that means that's a shorter period of time for someone to potentially crack and figure out your keys. So that's still helpful. If you have any key rotation schedule at all, if you have the means to rotate your keys, that is huge. Because if you find out, oh crap, someone did kind of get at those, well, hey, rotate them now. Done. You're fine. Well, once you figure out what was exfiltrated, but that's not my problem right now. Misconfiguration. Even with solid crypto, misconfiguration is one of the biggest problems. This starts to dovetail in with insecure defaults, which is on a later slide, but basically, the math for good crypto is solid. I trust the math. But figuring out how to get the libraries actually up and working and securely can be a royal pain in the ass. If you've ever had to set up a tunnel with Windows Communication Foundation, that way lies madness. But it can be done. The crypto is solid, but holy crap, actually getting it working, very frustrating. Again, browser security directives. You can do things like tell browsers not to cache data. If you, say, have a banking website, or you're repeating sensitive data, personal data to your users, tell the browser, hey, don't actually cache this, thank you much. Because then if someone gets to their browser, looks through browsing history, if that data wasn't cached, it's not there to be stolen. Again, don't hold on to information you don't need in the first place, but I'm sure that everyone has a business need for holding on to social security numbers. So I'm going to just make a quick side note on writing your own crypto. If you tell me that you wrote your own crypto, I will regard you like a child. Also, if you don't follow InfoSec Taylor Swift, you really should. That account brightens my day multiple times a day. It's one of these awesome 1%er jokes. People who understand pop stars and InfoSec jokes. It's really great. But again, so we're talking about sensitive data exposure. There are easy ways to take care of this. Again, SSL, I harped on that. I'm going to keep harping on that. Various relatively recent flaws in popular SSL libraries notwithstanding, it's still a good idea to have crypto, just, configure it. Hash your passwords properly, good crypto, salted hashes. key stretching is a good thing. Bcrypt, PBKDF2, et cetera, et cetera. If you're, for the actual hash algorithm, SHA-3 is good, RIPEMD320, Whirlpool, these are all fancy and fairly recent, but still they've been kicked a lot, and they're good. But if you're in a situation where, say, you have to do FIPS compliance in a weird way so that good algorithms aren't readily available, you have to deal with key stretching. And so instead of key stretching through Bcrypt for a work factor of 20, you'll have to maybe adapt to SHA-1 with an equivalent work factor of, 2,000 or something ludicrously huge. Question? That's good to know. Problem is, with one of my clients, the server actually has a registry flag set forcing use of FIPS-approved encryption libraries. So we're like, no, we actually give a shit about what we do. So we put in some massive key stretching options. We give our users a chance to switch to Bcrypt, but if they really want to use something, or I think it's Bcrypt with, I forget what algorithm we use as the core of it, but if they really want to use something weak, sure. If you really want to, say you've got the registry flag set, but we're going to work factor the hell out of it. We're not going to make it easy just because they demand we use weak crypto. DOS, denial of service? Not really. The algorithm we're required to use is unfortunately so old and fast that the whole point, actually, generally, if you're concerned about denial of service, what you want to do is kick the user out after so many failed logins, give them a timeout, slow them down, flag that someone's trying to do something weird. Granted, someone could try to do a distributed denial of service with a bunch of different accounts, but theoretically, it shouldn't slow your system down if you get if someone's trying to access an account that doesn't exist. Just make them wait a bit and be like, yeah, thread sleep 3000. Okay, yeah, login failed. But it's actually important that you have more expensive password hashing, because if someone walks away with their password database, you want to make them work to get those passwords. Also, salted hashes. I'm not sure if you're familiar with the Adobe breach from however many months ago. There are people just looking like, oh God, no. Yeah, we know what the most popular passwords are, and no one even had to crack the ciphertext, because it's the same ciphertext for the same password. They did not salt the passwords. So yeah, 1.9 million people use the password 123456 because of a failure in using, the crypto is solid, but failure to implement or to use it properly. And this resulted in a lot of people kind of sad-faced. Like I said, comments in your JavaScript and markup, etc. Server comments are freaking cool. You have comments in your markup, and you could see them as a developer, but they don't render out to the actual web page. Extremely handy. You can say comment out large swaths of code. You can comment out what, say, Stack Overflow questions you're following that might be relevant. You can prevent your name from being Googled in or searched in Stack Overflow because your name happened to show up in some code that someone's trying to attack. Similarly, custom error pages. If you're dumping stack traces to your users when your site dies, you're telling people things they don't need to know. But set up a custom error page. It just says, hey, something went wrong. Try again, maybe. Secretly email or log to the database whatever happened, for actual information to debug it, figure out what happened. But don't tell the users things they don't need to know. They just don't need to know that crap. Anti-caching directives, again, I think I mentioned them on the previous slide, or 2 slides ago, I kind of jumped the gun there. Not universally supported, but they still help. If 80% of your users are not caching their banking pages or banking data, personal info, that's still 80% of your users who don't have personal info that can be stolen off of their machines. It's still helpful. It's not perfect, but it helps. Next up, security misconfiguration, which shockingly sounds a lot like what I just harped on, but somehow, like I said, OWASP special sauce, and they split points apart and group them in weird ways, which is why I grouped them the way I did. Security misconfiguration is fun stuff, except it's really not. Out-of-date software is common. Figure out how to install your Windows updates. I know uptime is important. That's when you make money. You don't make money while you're installing Windows updates, or at least your company doesn't. Figure out a way of doing this. If you can do multiple servers, round robin, update one server while the other's still serving banking transactions, then bring that one down for updates when the first one comes back. Find out a way of updating your software. I'm ranting on about the next slide. Too bad. Unnecessary features are a common problem. Say if you have, I don't know, Flash or Java installed on your machine. That's kind of, something people can attack you through. Insecure defaults are a common thing. Say leaving the guest account open or giving users permissions they're not supposed to have. Or say user accounts with too much power. Say, I don't know, the DB user that your web app uses to connect to your database might also have truncate and drop and create permissions. Why does your website need that? Unless you're writing PHP MyAdmin, which I don't know why you would, apart from providing a vital service to people learning how to write websites, I guess. But user accounts shouldn't have those permissions. If someone, say, digs through your configs, magically guesses the user account that your website uses, that's kind of a keys to the kingdom sort of thing, because that account can do anything your website can do. Misconfigured crypto. Hey, I think I already harped on that. If you're, say, using weak keys, or if you're using the wrong cipher block mode, kind of a common thing. And this isn't really an easy one to fix. It's tedious. Like I said, installing updates, management sometimes says, what the F are you doing? Every time that server is down, we are losing money. Well, yeah, but you're also subject to someone stealing money. Things you don't need. I just say uninstall Java. I know there are a lot of Java developers who would probably take umbrage with this. And I'm sorry, but every time a Java update comes out, there are a fistful of critical vulnerabilities that kind of make me cringe. Another option is another item of turning off things is turn off unneeded handlers on your web server. If you're running, say, an MVC site and you don't need the ASP.NET Web Forms handlers, just turn those off. If you don't need them, don't run. They're taking up CPU, and it's just less attack surface. Custom error pages I harped on. .NET request validation. Oh, hey, we come back to that. Again, by default, .NET request validation is turned off, and custom error pages are turned off because it's trying to help the developer get their site working. But when you're getting into production, you need to turn those features back on. .NET request validation is kind of simple, like I said. It's not perfect, but turn it on. It's a safety net. It'll save you more than you realize. AppsDB users with permissions it doesn't need. Oh, hey, I talked about that too. I'm really out of order here. More or less, it boils down to principle of least privilege. Again, this is a trope in the InfoSec community. We all know this, but it's still a thing that deserves repeating. So the next one up is, again, dovetails very closely with the last 2 points. Funny. Not installing updates promptly. Yeah, that's basically insecure configuration. Wait, crypto. I feel like I've already been here. Old versions of Flash and Java, that's exceedingly commonly attacked. So, question? Sorry. That is an excellent point, and I like that a lot. I don't know if it was recorded, but the point was write something in your code that checks the versions of whatever installed libraries you rely on and kicks the user out if they're using a less than recent version. The counterpoint to that is sometimes people write these big business applications that rely on old versions, and new versions might have different APIs that break things. And maybe business isn't willing to spend the dev time on rewriting the app to fix it. This is more common than it should be, and it's really sad. It makes me sad. Thankfully, my boss listens when I rant about this stuff. I prefer your world. I prefer your worldview. It's just that I don't believe that's universally true, and it's kind of scary. Mm-hmm. Okay, so what I need you to do is put together a talk for next year on how to talk to people above you to get whatever security thingies done that you need to be done. That's a talk that needs to happen. Unfortunately, my main focus right now is being a developer and not leaving my screen because I desperately need the photosynthesis to stay alive. But components with known vulnerabilities. So who remembers that scene in Men in Black 2, where Kay gets his memory back, and Jay's like, no, the car's mine now. You drive the old and busted, I drive the new hotness. You always want the new hotness, trust me. Install updates, I've harped on that again and again, freaking do it. There's performance boost, there's new features, there's other happy stuff. If you can, stay aware of news regarding your frameworks and all of your tools. You never know what interesting things will bubble up in a mailing list that maybe a week later it's all over the news and you'll say, oh, yeah, they were emailing about that before. We've already stopped using that API. Use proven crypto. Oh, man, this still sounds very familiar. I think I've gone over like 4 slides talking about proven crypto. So your point about having to use older frameworks, or I guess it was more toward my point because I wrote these slides ages ago. If you have to use an older library because business won't let you put in the time because they won't listen, you can write secure wrappers around insecure components. It's not great. It's kind of giving up and saying, fine, but at least have some pride in your work and try to lock things down. It's better than having a huge breach and then business is like, well, you were talking about having insecure blah, 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 and since we got owned, you're fired because you spoke up. I can't imagine companies would actually do that. Oh, wait, I can. But anyway, oddly enough, we are getting toward the end, and I went through this way faster than I expected. Man, nerves were a good idea. So I'm going to give you a simple way to look at this, wrap it all up in some pithy statements. First off, all user input is always malicious. Silly question. Any gun owners in here who are willing to raise their hands? Okay. So as part of gun safety training, it starts with every gun is always loaded. And it continues on, be sure of your target, be sure of your backstop. In other words, know what you're actually shooting at and know where the bullet's going to go if you miss. Again, user input's always malicious. Be sure of your user and be sure of what the hell they're trying to do. Never underestimate the power of a stolen set of credentials. Anything you say can and will be used against you. If you're leaking information, say stack traces, comments, things like that, an attacker's going to find that. And they're going to find what the hell is wrong with your code and abuse the hell out of it. Work with your config team. As a dev, there's a sort of a common trope about the devs want all these features enabled because they want to get their shit done, and ops is saying, no, this is insecure. We can't just enable all this crap. We're not installing all these libraries. That's insane. Work together, find out a reasonable compromise from a secure perspective, figure out the appropriate configuration values, figure out what you actually need, because it's very common that devs will say, oh, new shiny toy, we want this. You might not actually need that, but sometimes you actually do. Who knows? Work with them, not against them. As a dev, I used to be a sysadmin for a bit. I stopped doing that because I really hate the 2 a.m. Nagios alerts. Also the hair on fire panic modes because the server is shitting. Another point? I still have I have a Xenos shirt from Ohio Linux Fest years ago. I still wear it sometimes. Well, yeah, meet me at the open bar later. I want to hear that story. Again, config team is there to help you. They might not sound like it sometimes. That's probably because they're sleep deprived because your application just shit gigabytes of customer data at 2 a.m. and they had to figure out why the IDS was throwing up. Play nice with config, please. They're good people. So, pretty much all I got. Thank you very much for listening. Last chance to contradict me if I was wrong. Video's still recording. Hell, I've got 5 minutes left. Anything that's confusing, tell me to speak up or something. OWASP.org, they have an F-ton of information there. Check them out. My other resource, Troy Hunt, is a fairly well-known .NET developer. He wrote a guide for the previous round of the top 10, and it goes into a lot of detail describing the various points and good remediation strategies. The OWASP top 10 did not change a whole lot from 2010 to 2013. They split a couple items, combined a couple other items, but it's largely the same thing. Injection is still number one, shock. But yeah, any questions, points, counterpoints, arguments, stuff like that? No, really? Dang. Well, if anyone else is listening, cyber.